Good evening to one and all. Today in this live lecture we shall solve the number of problems or the examples based on inverse Laplace transformation. Actually, in the last lecture we have seen the concept regarding inverse Laplace transformation, definition of inverse Laplace transformation. Now in this lecture we have to discuss some important examples related to the inverse Laplace transformation. That means we have to use this. Okay. Now, actually, Laplace transform L of f of t is equals to capital F of p is equals to integral from 0 to infinity e raised to minus pt into f of t dt. This is the basic definition of Laplace transformation. Now, if the Laplace transform of f of t, this is the definition of inverse Laplace transform. If the Laplace transform of small f of t, which is equals to capital F of p, then small f of t is called inverse Laplace transform of capital F of p. So, if Laplace transform of small f of t is equals to capital F of p, then L inverse of capital F of p is equals to small f of t. That means small f of t is called as a inverse Laplace transform of capital F of p. Where L inverse, this is the operator and which is called as inverse Laplace transform operator. Now, the basic relations between Laplace transform and inverse Laplace transforms here. You know that Laplace transform of 1 is equals to 1 upon p, then inverse Laplace transform of 1 upon p is equals to 1. Do you know? Again, Laplace transform of e raised to at is equals to 1 upon p minus a, then L inverse of 1 upon p minus a is equals to e raised to at. In this way, we can obtain the inverse Laplace transform. Okay, so again, there are some properties regarding the inverse Laplace transform. This is the linearity property. L inverse of C1 capital F of P plus C2 capital F of P is equals to C1 L inverse. 1 minute. C1 L inverse of F of P plus C2 L inverse of F of P. In this way, 1 minute we can write this. C1 L inverse of capital F of P plus C2 L inverse of capital F of P. See, this is the basic formula regarding inverse Laplace transformation. Similarly, the first translation or first shifting, L inverse of f of p minus a is equals to e raised to at into small f of t. Second shifting or second translation, e raised to L inverse of e raised to minus ap into capital F of p is equals to f of t minus a into h of t minus a. Or we can write t is greater than or equals to 0. If t is greater than or equals to a or t is greater than a, then we can write f of t minus a. Again, L inverse of f of 1 upon f of a into 1 upon a into f of p divided by a, which is equals to f of small f of at, or L inverse of capital F of ap is equals to 1 by a small f of t by a. These are the inverse Laplace transformation properties. Okay. By using these properties, some of the examples which we have solved yesterday. Also, if you have not written this, then you can write this after the completion of the syllabus. स्टुडंट कुणीही लेक्चर आता लिहून घ्यायचं नाही, फक्त समजून घ्या, सर्वांनी समजून घ्या. काही क्वेश्चन असेल तर विचारा चला, परंतु कुणीही या ठिकाणी कंटिन्युअसली सोबत लिहून घ्यायचं नाही. लेक्चर संपल्यानंतर लिहून घ्यायचं, फक्त अगोदर समजून घ्या. फर्स्ट ऑफ ऑल यू हॅव टू अंडरस्टँड फर्स्ट, देन after completion of this lecture you can write. So L inverse of, 1 minute, L inverse of integral from p to infinity capital F of u du, we can write small f of t dt. In this case, in each cases, Laplace transform of small f of t is capital F of p. This is the basic formula you must know. Then L inverse of p into capital F of p is equals to f dash of t when f of 0 is equals to 0. Again, there is one important property. If f of t is a piecewise continuous and its exponential order e raised to c naught t such that limit t tends to 0, small f of t divided by t exists. This is a condition for derivative and integration. So L inverse of capital F of p divided by p is equals to integral from 0 to t f of small f of u du when p is greater than c naught. Next, L inverse of dn by dp raised to n capital F of p is equals to minus 1 raised to n t raised to n into f of t. These are the basic Laplace transformation. These are all basic inverse Laplace transformation properties. Now next we have to solve the problems based on this. Now first problem, actually this is the fifth problem. Yesterday we have solved one theorem and 4 different problems. Now first of all, we have to find out the Laplace transformation of the function capital F of p is equals to p minus 1 divided by p square minus 2p plus 5. So first of all, we have to convert this into the linear term. To complete this linear term, we have to write last term as like a square plus 2ab. Then we need one last term, that is b square. Then we can write a plus b bracket square, complete square. So we have to convert this quadratic expression in terms of linear square. So this is the first term, this is second term. We need a last term. So there is one formula for the last term. What is that formula? Last term is equals to 1 by 2 coefficient of p bracket square. So 1 by 2 into minus 2, that is equals to plus 1. That is equals to plus 1. So we have to add this plus 1 and subtract this plus 1 from 5. We need here plus 1. So we can write 5 can be replaced by 1 plus 4. Now p square minus 2p plus 1. So we can write p minus 1 bracket square. Numerator is as it is, p minus 1 bracket plus denominator p minus 1 bracket square plus 4. So by using the first shifting property, what is that first shifting property? L inverse of capital F of p minus a, which is equals to e raised to at into small f of t, or L inverse of f of p. Okay, so we can write this first shifting property, p minus 1 divided by p minus 1 bracket square. Therefore a is 1. So e raised to at means 1t. L inverse of p divided by p plus 4. And according to the formula, p divided by p plus 4, in this case, p divided by p plus 4, L inverse of Where is that? 1 minute. This is the, okay, no problem. P inverse of P plus 4, I have not written here. So we can write this is a P square plus 4. And P inverse of P square plus 4, that means we can write L inverse of P divided by P square plus 4 means 2 square. 4 means 2 square. So P divided by P square plus 2 square. Then we can write this formula, formula number 3. It can be represented by L inverse of P divided by P square plus A square, which is equals to cos 80. So we can write this as cos 80. Okay. So thus we can write e raised to t into cos 2t. Now problem number 6, we shall move towards the problem number 6. Capital F of P is equals to 5p plus 7 divided by P square plus 5. So Laplace transform of this, separate this denominator, 5p divided by P square plus 5 plus 7 divided by P square plus 5. So you can take 5 out of this inverse Laplace transformation. So 5 into L inverse of P divided by P square plus 5 plus 7 into L inverse of 1 divided by P square plus 5. So P divided by P square plus, we need A square, because for the comparison with the standard formula, standard property, we need A square. Therefore P divided by P square, we can write root 5 means root 5 square. So A is root 5. P divided by P square plus A square, we can write cos 80. 80 means root 5. 7 divided by L inverse of P 1 upon P square plus A square. And 1 upon P square plus A square, then we can write 1 by A sin 5t. Okay. Actually, the basic formula is A divided by P square plus A square. But we can write this formula 5 by 7. Okay, as it is. Now, next problem. Student, you don't write problem with me. You can write after the completion of this lecture. So, first of all, your concentration, first concentration is on how to solve this problem. Okay, that means understanding must essential, then you can write. So Laplace f of p is equals to 2 divided by p minus 3 bracket raised to 5. So L inverse of capital F of p is equals to L inverse of 2p divided by p minus 5 bracket square. Okay, 1 minute. Okay, so you can write 2. You can take out of this inverse p divided by p minus 5 bracket square. You have to adjust for the shifting property. Denominator is p minus 3. So you have to write p minus 3 plus 3. Then p minus 3 in a bracket plus 3 divided by p minus 3 bracket raised to 5. Then you can use first shifting property, that is L inverse of f minus a means 3. So e raised to 3t L inverse of p plus 3 divided by this complete p minus 3. By using the shifting property, you can write p. So p plus 3 divided by p raised to 5. Again separate this denominator. P divided by p raised to 5 means 1 upon p raised to 4. And 3 divided by p raised to 5. Now 1 upon p raised to 4. Actually, we have to use the L inverse of, what is that formula? 1 upon p raised to n plus 1. The basic formula, which is equals to t raised to n divided by n factorial. By using this formula, you can write 1 upon p raised to 4 means t raised to 3 divided by 3 factorial plus 3 as it is. 1 upon p raised to 5 means t raised to 4 by 4 factorial. And after solving this problem, we can get the answer. Next, problem number 8. See this. L inverse of 6p minus 4 divided by p square minus 4p plus 20. So L inverse of 6p minus 4 divided by p square minus 4p. Now for complete square of these two terms, we need 4. So you can take 4 from 20, that means p square minus 4p plus 4 plus 16. So it will be p minus 2 bracket square plus 16. Now again we need this p minus 2 in the numerator. In place of p, first shifting property we have to use. So in the numerator there is also need minus p. In place of here p, we need p minus 2. That means 6p minus 12. So we need minus 12. After multiplication of 6, we will get 6p minus 12. That means we need minus 12. So you can take minus 12 for minus 12 plus 12 and minus 4 as it is. So you can take a common 6 from this. So 6 in a bracket p minus 2 plus 8 minus 12 minus 4 means 8. So 6 in a bracket p minus 2 plus 8 divided by p minus 2 bracket square plus 16. Okay. So we can write this as, by the first shifting property, f of p minus a means here minus 2. So e raised to at plus L inverse of 6p plus 8 divided by p square plus 16. Now you can separate denominator for first term and second term. So 6 as it is, L inverse of p divided by p square plus 16 means 4 square plus 8, again separate this, L inverse of 1 upon p square plus 4 square. So according to the definition of the inverse Laplace transform, 6 as it is, p upon p square plus 4 means cos 4t plus 8 as it is, 1 upon p square plus 4 square means 1 by a sin 80. Thus we can write the solution, e raised to 2t is equals to 6 cos 4t plus 4 sin 4t, which is equals to as it is. Now we shall move towards the next example. Evaluate L inverse of 1 upon root 2p plus 3. That means we have to write L inverse of 1 upon root 2p plus 3, which is equals to L inverse of 1 upon, you can take root 2 common from root. So root 2 is equals to, remaining term is 3 p plus 3 by 2. And in root, we can write p plus 3 by 2. Now convert this root into its power. So we will get p plus 3 by 2 bracket raised to 1 by 2. Again you can take this out of inverse Laplace transform. So 1 by root 2 L inverse of 1 upon p. Now we have to convert this plus 3. You can write minus p minus 3 by 2 whole bracket raised to 1 by 2. So now this is one formula which we have to use. Here first of all you have to use the shifting property, that is equals to e raised to minus 3t. Okay, e raised to minus 1 by root 2 as it is, e raised to minus 3 by 2t, L inverse of 1 upon p raised to, after shifting property that goes to p. So p raised to 1 by 2 means root p. Again there is one formula which we have seen. L inverse of 1 upon root p means 1 by root pi. We have to use 1 by L inverse of root pi upon root p. There is one formula. So we have to adjust. We have to divide by root pi, multiply by root pi. So we will get 1 by root 2 e raised to minus 3 by 2t, 1 by root pi, L inverse of root pi by p. And we know that the basic formula, L inverse of root pi by p, which is equals to 1 upon root t. So its Laplace transform is t raised to 1 by 2, or we can write this again, 1 upon root 2 pi into e raised to minus 3 by 2 into 1 upon t raised to 1 by 2 means root t. So it is also in the simplified form, e raised to minus 3 by 2 divided by t divided by root 2 pi t. Okay, so thus we will get the answer, complete answer. Okay, no problem. Now we will say नेक्स्ट, अरे स्टुडंट, इफ यू हॅव एनी डाऊट देन यू कॅन आस्क मी. थोडं मी फास्ट प्रॉब्लेम घेतो, प्रॉब्लेम्स खूप आहेत आणि इथं प्रॉब्लेम मी ऑलरेडी सॉल्व्ह करून ठेवलेले आहेत, कारण पेन व्यवस्थित चलत नाही लाईव्ह मध्ये, त्यामुळं पेन अगोदर प्रॉब्लेम सॉल्व्ह करून ठेवले. जास्तीत जास्त प्रॉब्लेम व्हावे या हेतून. तुम्हाला जर काय अडचण आली प्रॉब्लेम सोल्युशन मध्ये तर तिथंच विचारा. चला, नाव सी दिस. फाइंड द लॅपलास ट्रान्सफॉर्म ऑफ 3p plus 7 divided by p square minus 2p minus 3. Actually, we have to find out the Laplace transform of this. The same problem, L inverse of 3p plus 7 divided by p minus 1. You can adjust this. P square plus minus 2p. We need plus 1. So p square minus 2p plus 1. Then we will get p minus 1 bracket square. p minus 1 bracket square minus 4 and numerator मध्ये 3p plus 7. So L inverse of 3 into p minus 1 plus 10 divided by p minus 1 bracket square minus 4. So e raised to t into L inverse of 3p plus 10 divided by p square minus 4. So e raised to t into 3 into L inverse of p divided by p square minus 2 square plus 10 L inverse of 1 upon p square plus 2 square. So e raised to t into 3 cos h to t plus 10 by 2 sin h to t hyperbolic function, and this gives the result same. Do you understand this? हे समजलं का रे? This is a p square minus a square, and if p divided by p square minus a square, this is a formula for inverse hyperbolic function. This inverse Laplace transform is for hyperbolic function. Okay, समजते का? Yes or no? Next, we shall move towards the next problem. L inverse of 2p plus 3 divided by 4p square plus 4p plus 5. Okay, so Laplace transform of this 2p plus 3 divided by 4p square plus 4p plus 5. First of all, for the completing square, for the substitution, addition and subtraction of last term, we need square coefficient 1. We need square coefficient must be 1. So you have to take 4 common from denominator. So 1 by 4 L inverse of 2p plus 3 divided by p square plus p plus 5 by 4. Now p square plus p, we need a last term which will convert bracket square. So what is the formula for last term? Actually last term is equals to 1 by 2 coefficient of x or middle term, coefficient of p bracket square. Middle term means 1 by 2 coefficient of middle term is 1 bracket square, म्हणजेच 1 by 4. ठीक है? So we will get this result 2 p plus 1 by 4. So we can write p plus 3 by 2 divided by p plus 1 by 2 bracket square plus 1. So p plus 1 by 2 plus 1 divided by p plus 1 by 2 bracket square plus 1. Is it okay? So 1 by 2 e raised to minus 1 by 2 t L inverse of p plus 1 divided by p square plus 1. That means Laplace transform of p divided by p square plus 1, L inverse of 1 divided by p square plus 1. So its value is cos t and its value is sin t. Okay, thus we can get the solution of the Laplace transform. Okay, hello हाँ बोला. थोडं एक 5 मिनिट एक 9 वाजता होतं, थोडं ऑनलाईन लेक्चर चालू आहे. येस, ओके. तर we have to find out the Laplace transform of the function such that here we can find the value of Laplace transform. So one minute. हाँ एक मिनट रे okay 1 minute. So we can write this as 1 by 2 e raised to minus 1 by 2 t p divided by p square plus 1 cos t sin t. Is it okay? Right. Next. Now, next we have to find out the L inverse of p square plus p plus 2 bracket raised to 4. That means we have to find out the Laplace transform of okay, the Laplace transform of how we can write ठीक है. Now we can write here L inverse of p square plus divided by p plus 2 bracket raised to 4. Now our aim is to find out the Laplace transform of inverse Laplace transform of this. First of all, in the denominator there is a p plus 2. So we have to use the shifting property. So we need in the numerator also p plus 2. So keep this bracket square as it is p plus 2, and for this plus 2 we need minus 2. Then by using the property first, by shifting property you can write L inverse of f of capital F of p minus a, and that will be f of t. So we can write this as e raised to 2. A means here minus 2, e raised to minus 2t, L inverse of p minus 2 whole square divided by p raised to 4. So p minus 2 bracket square means a square minus 4p plus 4. A minus b bracket square expansion we have used here, therefore divided by p raised to 4. So we get the inverse Laplace transformation. Hmm. 1 minute. So we can write this as a e raised to minus 2t L inverse of p square minus 4p plus 4 divided by p raised to 4. So e raised to minus 2t into L inverse of p square divided by p raised to 4 minus 4p divided by p raised to 4 minus 4 divided by p raised to 4. Hello madam. Hello madam. Hello. So, hello madam. नमस्कार madam, नमस्कार. असं आहे का? बरं. अच्छा अच्छा. अच्छा मॅडम मी एक मॅडम 15 मिनिटांना लावू का मॅडम? थोडं ऑनलाईन लेक्चर चालू आहे. हां प्लीज मॅडम प्लीज. ओके ओके. So e raised to minus 2t into L inverse of p square divided by p raised to 4 minus 4p divided by p raised to 4 minus 4 divided by what is the remaining term? P raised to 4. Okay. Now see this next. So we can write 1 upon p square minus 4 by p cube plus 4 by p raised to 4. So by using the inverse Laplace transformation, so here we have L inverse of 1 upon p square minus 4 divided by p cube plus 4 divided by p raised to 4. So L inverse of 1 upon p square is t raised to 1 divided by 1 factorial. L inverse of 4 by p cube is equals to t square divided by 2 factorial. L inverse of 4 divided by p raised to 4 is 4 as it is t cube by 3 factorial. So this is the final answer. Thus we get the final answer for Laplace transform L inverse of p square divided by p plus 2 bracket square. Okay. Now we shall move towards the next problem. Find L inverse of 1 upon p minus 1 in the first bracket, second bracket p minus 2, in third bracket p plus 4. So first of all, we have to calculate the Laplace transform of multiplication of 3 bracket. But there is no any formula directly for the multiplication of 2 bracket, and we can't use the shifting property directly here because the combination of brackets are not same. So we have to use another method here, and that method is called as a partial fraction. First of all, we have to convert this product form of denominator in the form of addition and subtraction, and this method is called as partial fraction. So by using the partial fraction, we have to convert this 1 upon p minus 1 into p minus 2 into p plus 4, which is equals to 1 upon p minus 1 plus a upon p minus 1 plus b upon p minus 2 plus c upon p plus 4. Actually, you must know the types of partial fractions. तुम्हाला पार्शियल फ्रॅक्शनच्या टाइप्स माहित असणं गरजेचं आहे. तरी मी तुम्हाला या ठिकाणी पार्शियल फ्रॅक्शनच्या टाइप्स लिहिता येतं का लिहून दाखवतो. ठीक आहे. हा, पार्शियल फ्रॅक्शनच्या वेगवेगळ्या टाइप्स असतात. त्यामध्ये पार्शियल फ्रॅक्शन कसं करायचं काय नाही याचं तुम्हाला मी लिहून दाखवतो. सपोज, ठीक आहे, त्याचा टेबल इथं बसायचं नाही, असू द्या. You can write, see this, if there is a first bracket, second bracket, third bracket, then we have to convert this into the partial fraction, that is a divided by a, b, c are the partial fraction constants which we have to calculate. So 1 upon p minus 1 into p minus 2 into p plus 4, we have to convert in the partial fraction a divided by p minus 1 plus b divided by p minus 2 plus c divided by p plus 4. So 1 is equals to a into p minus 2 into p plus 4 plus b into p minus 1 into p plus 4 plus c into p minus 1 into p plus 2. How we have, that means we have to take the LCM of this denominator. On the right side, if we take the LCM, then p minus 1 into p minus 2 into p plus 4. This is the denominator of right side. This denominator will be get cancelled with the denominator of the left side. So remaining terms are numerator 1, which is equals to, after LCM we will get a into p minus 2 p plus 4 plus b into म्हणजे त्याचा डिनॉमिनेटर सोडून द्या, p minus 1 p plus 4, p minus 1 into p plus 4 plus c into p minus 1 into p minus 2. Again, now we have to calculate the values of A, B, C. Consider this is equation number 2. To find the values of A, B, C, we have to first of all convert these brackets into 0. That means p minus 1 bracket, p minus 2, p plus 4. These brackets we have to convert into the 0. Then that means to obtain the value of A, we have to convert b and c into 0. There is a common bracket with b and c is p minus 1. So we have to select p in such a way that p minus 1 goes to 0. So put p is equals to 1, then p minus 1 goes to 0, p minus 1 goes to 0, then b goes to 0, c goes to 0, remaining term. So put p is equals to 1, then 1 is equals to 1, a into 1 minus 2 is again minus 1, p 1 plus 4 is 5, plus b into 0, c into 0. Thus we will get the value. What is that value? The value p is equals to minus 1 by 5. Again we have to calculate the value of b. Simultaneously we have to convert a and c into 0. There is a common bracket in between a and c is p minus 2. So first of all we have to convert p minus 2 into 0 by putting p is equals to 2. If we put p is equals to 2, then simultaneously a goes to 0, c goes to 0, and we can find the value of b. So 1 is equals to a into 0, c into 0, b into 1 into 6 after putting p is equals to 2. So we will get the value of b as 1 by 6. Next, similarly, we can put p is equals to minus 4. Then a goes to 0, b goes to 0, c into minus 5 minus 6, c will be 1 by 30. Thus, we have to put the values of a, b, c in equation 1. Then this equation 1 in the partial form becomes, in place of a, b, c, put these values. So we will get the result minus 1 by 5 upon p minus 1 plus 1 by 6 upon p minus 2 plus 1 by 30 upon p plus 4. Now we have to calculate the inverse Laplace transform. So L inverse of 1 upon p minus 1 into p minus 2 into p plus 4 is equals to L inverse of minus 1 by 5 divided by p minus 1 plus 1 by 6 divided by p minus 2 plus 1 by 30 divided by p plus 4. So L inverse of this, and we will get the result this. Do you understand, students? समझला का रे? If you have any doubt, then you can ask me. Next, we shall move towards the problem number 14. This is a very important problem. Actually, these three problems are very important here. 13, 14, 15. These are the very important problems. So you have to follow perfectly these problems. Okay. So L inverse of 2 divided by p plus 1 divided by p square plus 1. Again, we have to use the Laplace partial fraction to convert these two brackets into the addition form. The product of these two brackets we can convert into the addition form. Now here we have to use the Laplace transform. Which type of Laplace transform? We have to use the partial fraction if here, if you have ax square plus bx plus c divided by x plus p and x square plus q.